Thank you for joining this lesson. We're going to discuss variations number 18. A quantity y varies directly as the square of x and inversely as the square root of z. Given that y equals to 16 when x is 4 and z equals to 25, find the equation connecting y, x, and z for 3 marks. Remember to subscribe and to share this lesson with your friends. So the quantity y varies directly as the square of x. That means as the square of x, and inversely, that means divided by the square root of z. The square root of z. So that is the general equation. But now we can replace the symbol of proportionalism with a constant. So y is equivalent to, now we introduce a constant of proportionality, x squared out of the square root of z, out of the square root of z. So we are told that the value of y is 16. We can now substitute when, there is a k here, x equals to 4 and z equals to 25. So the square root of 25. We're going to have 16 being equal to 16k out of 5. That means we can multiply by 5 all through, and 16k will be 16 times 5. That means for us to get the value of k, we need to divide through by 16 and k becomes 5. Now the equation connecting y, x, and z is the equation here, but now with a known constant. So the value of y equals to 5 x squared divided by the square root of z. So that is how we handle the first part on joint variations. The second part I can see is on percentage changes. If x is increased by 20% and z decreased by 30%, find the percentage change in y for 3 marks. So for us to get percentage change in y, we should know that the initial value or expression for y is k, x squared out of the square root of z. But here comes more instructions which are telling us that the value of x increases by 20. That means we got a new x now. Can call it new x, which increases by 20%. So it's 120% of original x. That means the new x is 1.2 original x. And also y changes by decreasing by 36. That means the new y becomes 64% of the original y. And this is 0.64 original y. So the new y is 0.64 original y. The new x is 1.2 the original x. That means now we can get z decreases. Do you know that this is z and not y? So the new z is the one becoming 64% of original z. So the new z is 0.6.4 of original z. So the new z becomes 0.64 original z. 0.64 of original z. The new z is 0.4 original z. Sorry for the mistake. Now we can proceed and say, now that this is the new x and the new z, then there must be a new expression for y, which means the constant, the new x squared, 1.2 squared, divided by the square root of the new z, which is 0.64 of original z. So the new y becomes, when 1.2 gets squared, we get 1.44. So we will have 1.44 constant x squared divided by, when we take square root of everything, we shall end up having 0.8 root z, because in the denominator the square root of 0.64 is known, but that of z remains unknown. We can divide this and say this is the new y is 1.8 k x squared divided by the square root of z, Now we can proceed and get the percentage change in y, because we have the new y, we have the original y. So we should know that a percentage change in y is going to be original y minus the new y minus original y, that is the change in y, then out of original y multiplied by 100 to make it percentage. This means we will need to take 1.8 kx squared divided by the square root of, this is the new y, minus the original y, which is kx squared divided by the square root of z, then divided by the original k x squared out of the square root of z. We can factorize k x squared out of the square root of z, and remember, because it's a percentage change, there is the times 100 generally. So when we factor out this in the numerator, we shall remain with 1.8 minus 1, and in the denominator we are already having k x squared out of the square root of z. That means kx squared out of the same, the square root of z cancels, the whole of this cancels, and we'll have 1.8 minus 1 multiplied by 100. So 1.8 minus 1 then multiplied by 100 becomes 80%. Now that this change is positive, we can say it's 80% increase. 80% increase. So we call it an increase because the change is positive. Finally, we got a part B here, which says the cost C per day of feeding examiners in a marking center partially varies as the number of senior examiners is present, and partly inversely as the number of ordinary examiners P present. It costs 32,000 shillings to feed 30 senior examiners and 400 ordinary examiners. The cost of feeding 80 senior examiners and 640 ordinary examiners is 41,250 Kenya shillings. Find the cost of feeding 100 senior examiners and 500 ordinary examiners. Therefore, we're going to, this is partial variation because we are told the cost C. This is how it varies. Partly as the number of senior examiners S, and partly inversely, that one should be taken very seriously, the number of ordinary examiners present. This means we introduce two constants of proportionalism equals to a constant K times S plus another constant multiplied by 1 over P. In this case, we must know that C and K are just constants. C and K are constants. We can find the value of these constants by saying that now that C is known to be 32,000, this is equal to constant K times 60 senior. So 60K plus C out of when 400 ordinary are there. This is equation 1. And for equation 2, we have 41,250 equals to, that is to feed 80 senior times K plus a constant out of 640 ordinary examiners. So now with these two equations, we can solve them simultaneously and we be able to find the two constants. Let us, in the first equation, multiply through by 400 to do away with fractions. So that when 32,000 is multiplied by 400, this becomes 12,800,000. 12,800,000 equals to 60K. So 60 by 400 becomes 24,000 plus C. This is equation 1, whereby I have multiplied through by 400. Then you should know that there is a K here. Sorry, there is a K there. Then in the second equation, we multiply through by 640. So that 41,250 by 640 now becomes 26,400,000. 26,400,000 equals to 80 by 640. This is equal to 51,200 K plus C. This is equation 2. Now that the coefficients of C are just the same, we can directly subtract to eliminate C. That means we can subtract upwards, the value of C disappears, and 51,200 minus 24,000 becomes 27,200. This is K equals to, we can take 26,400,000 minus 12,800,000. This becomes 13,600,000, like that. So to remain with the value of K, now we have to divide through by 27,200. And K becomes 500 exactly. That means the value of C can now be obtained. The value of C is going to be, for us to get C, I can use the first equation. To get C, I will need 12,800,000 minus 24,000 times the value of K, which is now 500. So C is going to be 12,800,000 minus 24,000 into 500. And this becomes 800,000. C is 800,000. So now it means we have to write the original relationship now, this one now, but using known constants. So the cost C equals to, this is capital, this is small, a constant K, which is 500, multiplied by the number of senior examiners, plus a constant C, which has been known to be 800,000, out of the number of ordinary examiners. And finally, we are to find the cost of feeding 100 senior and 500 ordinary. 100 senior and 500 ordinary. That means now the cost is going to be 500 times 100 plus 800,000 out of the ordinary, which are 500. So the cost is going to be, when we divide 800,000 by 500, that becomes 1,600, then plus 50,000, we get 51,600 Kenya shillings. So that is how we handle the partial variation question. Thank you for following. Subscribe and share.